Hey math kids, today we're going to talk about points in space, and we're in chapter 9, section A. So I'm going to start off talking about just some ideas in 2 dimensions, and then we'll extend those to 3 dimensions. So imagine we had 2 points in space. The distance between those 2 points is going to be this orange line. We're also going to have a change in y, and we're also going to have a change in x. So that makes a right triangle, and we can use a squared plus b squared equals c squared, or in this case, delta x squared plus delta y squared equals our distance squared, if we think of this as our distance. If we just do a square root on both sides, we would end up with the square root of delta x plus delta y equals d. Move that over a little bit. Let me erase this just to be clear, so that just goes right there. Okay, and this is essentially the same formula because delta just means change in x, and so x2 minus x1 is delta x, and y2 minus y1 is delta y. Okay, so this distance formula, you can memorize it if you want to, or you can just think of it as the Pythagorean theorem, because it's really the same thing. Okay, the other thing is the midpoint formula. So midpoint formula for the same point xy if we have 2 points, x1, y1, x2, y2, that would have applied to this one as well, sorry. Midpoint is going to be just the average. So we just add them and then cut them in half. Now, if we're going to 3 dimensions, so all we have to do is add on the z. It's going to follow the same pattern. So for 3 dimensions, we just extend distance like that. For midpoint, we just get rid of this, do an ordered triple, but we're still taking the average. So we're just going to tack on z2 plus z1 over 2. And so that's kind of the idea of it. So let's go to example 1 and see how we use this.